Okay, so this is 2024 GCE question 6. So we have sine squared x minus 1 plus tan squared x cos squared x over sine x cos x is equal to negative cos x. Negative sine, cos x. So we shall talk about this part at the end of the video, and then we shall use an angle for x to verify this question at the end. Okay, so to prove this identity, we can start by changing this one. We know that tan squared theta is the same as sine. Tan squared theta is the same as sine squared theta over cos squared theta, like this. So we can write the other part exactly as it is. And then on the part of tan there, we can say sine squared theta over cos squared theta instead. Actually, we are using x there, so let's just stick to that. So by definition, an identity is a mathematical statement which is true for all the values of x in general. So if I should pick any x value, I should be able to get the same number on both sides of the equation. So I'll explain why I'm saying that. So let's expand. Cos squared times 1, this one will be cos squared x. Then cos squared times sine squared x, this will be sine squared x cos squared x, everything over cos squared x, then everything over sine x cos x. Next we have sine squared x minus, this is cos squared x. We have a cosine there and a cosine there. This will be sine squared x, and then everything over sine x cos x. My teacher of English said I should always dot my I's. Okay, like this. And then this is a well-known identity. We know that sine squared theta plus cos squared theta is equal to 1. The order doesn't matter. Remember, addition is commutative. So this one plus this is just the 1. Then everything over sine x cos x. So now when you look at this, let me just take the brackets out. When you look at this, it looks like the other side of the equation when you make sine squared x in the basic identity. Let me just show you what I mean. You have sine x squared plus cos squared x is equal to 1. So when I make cosine the subject, or maybe let me just make sine the subject instead, it will be much easier for you to see it that way. So we have this. So where we have sine, we can put this guy there. So this gives us 1 minus cos squared x minus 1, everything over sine x cos x, and then 1 will subtract with the other one there. So we have cos squared x, everything over sine x cos x. So now this and one of these two will go, so that we remain with negative cos x over sine x, and this is giving us negative cot x. So you can't take this one any further to get cos x. It's not possible. Cot theta, negative cot theta is not the same as negative cos theta. So there was a mistake on this question. Now, this is mathematics. You don't just say something without proof. So I'm going to show you that indeed this question had a mistake. So you can use any number of your choice and substitute in the x values there. And then if you are not getting the same numbers on both sides, then there is a problem with the question. So I think I can use 45 degrees. You can also use a 0, although you may have some difficulties if you are not very familiar with limits. So let's just use a 45 degrees. So the fact that 45 degrees works, or maybe is giving you a true mathematical statement, does not really prove the identity. It just shows that it's true for that particular number. But the moment you have something like 2 is equal to, let's say 0, or something like this is equal to this, then you know for sure that there was a mistake. In other words, inequality proves the identity wrong, and then equality does not prove the identity correct. I don't know if I'm making sense there. So let's try to take x as 45 or 30. Anyway, let's use 45. It's much easier to work with. So we can have sine squared 45 minus 1 plus tan squared 45 and then cos squared 45, everything over sine 45 cos 45, and then according to the paper this was equal to negative cos 45. So now from this triangle here, we know that both sine 45 and cos 45 is equal to 1 over root 2. So 1 over root 2, you square it, minus 1 plus tan, let me use square brackets here, 45 squared, and then cos 45 squared, everything over sine, why am I writing this? So tan 45 is just 1, and then cos 45 is the same as sine 45, so it's equally 1 over 2. Then on the denominator part, we have 1 over 2 multiplied by 1 over, root 2. Then this side we have 1 over root 2. So if you simplify this, you'll notice that the left hand side will not be equal to the right hand side. This is a half, 1 squared is a half, and then 1 plus 1 squared is a 2. This is multiplying by a half, and then everything over a half times a half is a half. 1 over root 2 multiplied by 1 over root 2 is just a half. So this one will give us a 1. So this will be 1 over root 2 minus 1. And then everything divided by this half there. So this minus this is negative half divided by half. This is giving us a 1, which is not equal to negative root 2. So this proves that the identity is not correct.